Good morning and welcome to our Socomec sustainability presentation. Just before we start the presentation, I'd like to remind everybody that this is Socomec's centenary year. It was founded in 1922. Thank you, and over to Richard for our presentation.
Well, thank you, Colin. My name is Richard Govia. I'm the Technical Director for Socomec in the UK, and obviously Colin Dean is our MD in the UK. So thank you very much, Colin, for the introduction. So today's agenda. So we're going to be looking at sustainability and a couple of points we're going to go through. What is sustainability? What are some of the key drivers? What are some of the key performance metrics that we can look at? And then some solutions that we can have a look at. So sustainability means different things to different people. If we look at the United Nations definition from 1987, their definition is meeting the needs of the present without compromising the ability of future generations to meet their own needs. And they set out 17 goals across a whole spectrum of areas. So zero hunger, quality education, gender equality. The one that we're going to look at today is goal number 7, affordable and clean energy. So this very much ties into the efficiency of data centres and how energy is used. One of the trackers, which is SDG 7, looks at the energy performance. Even though this is slightly out of date, 2018, you can see the UK is at 2.4, whereas the global average is 4.8.
Perhaps, Richard, you could explain the difference between the two figures and how it represents efficiency.
So the numbers represent a ratio between the energy supply and the gross domestic product. So the lower the number, the more efficient the country is at turning energy into output, in effect. Okay. So we've got a couple of slides now looking at the energy mix. This is from a BP report. It's the 2021 70th edition. So you can see BP's been producing this report for a number of years. The graph we're showing at the moment is the energy supply mix. Not surprisingly, green is oil. You can see green is still the dominant source of energy at the moment. Coal is still second globally, and the red one you can see here is natural gas, and you can see natural gas is on an increase at the moment.
And I guess this is quite interesting because in the current conflict we have in Ukraine and Russia, obviously natural gas is one of the products that Russia is exporting.
Exactly right, and we'll see in the next slide, how important natural gas is to the global supply. One really positive thing from the report: there were 358 terawatt hours of increase of renewable energy last year. That made up of wind was 173. And solar 148 terawatt hours. So a really positive number, but we still see too high a reliance on oil, coal and gas. If you look at the world energy mix, so the regional consumption, you can see the green is oil, which is still a huge proportion of the energy mix across all regions. Natural gas, again, such a key importance of the energy supply. See, Middle East is virtually half and half, so really dominant on the requirements of natural gas, and very little renewables. Renewables is at the top. CIS is the Commonwealth of Independent States, which is basically the old Soviet Union. So they're all blocked together in CIS. If we look at the energy mix per capita, not surprisingly, green at the top is North America. So you can see per capita, they are by far the biggest consumer of energy. CIS is second, which, as I said, is the Commonwealth of Independent States, the old Soviet Union. But you can see here, the orange is the Middle East. You can see that's increasing over time. So you can see there's a big disparity between regions and the energy mix per capita. One of the big consumers of energy is the data center market, which obviously Socomec are a key player in providing support and UPSs to that area. You can see here the flat market analysis. The forecast for 2022 is 2,500 terawatt hours.
Yeah, perhaps Richard, you could explain the meaning of flap.
So yeah, FLAP, sorry Colin. Yeah, FLAP refers to the European data center market. So Frankfurt, London, Amsterdam and Paris. So sorry, I should have said that. And you can see here on the right-hand side, the sort of turquoisey colour, that's London. So London is still by far the biggest player in the data center market, closely followed by Frankfurt, which is the darker colour. Madrid and Stockholm are catching up slowly. They're not on this graph, but they're being seen now as a key player for the big colos. The forecasted increase for between 2021 and 2022 is 353 megawatt of additional energy for data centers. So a huge increase in the requirements of the data center market across the European market. The demand is increasing, as I said, a huge increase between 20 and 2021. If you look back 20 years ago, Colin, a few megawatts was considered a large data center, whereas now a data center, if you're not looking at 20 to 50 megawatts, it's not considered a large player in the market. So the demands are only increasing for higher power data centers, larger UPS blocks. So along with the larger data center requirements, they want a larger UPS block. So if we look back 15, 20 years ago, 500 kilowatts was considered, a big block, wasn't it? Whereas now we're looking at 1 meg, 1.2 meg is the norm. And we're seeing that ourselves, and I'm sure our competitors are seeing it the same. Cloud computing, that really came to the fore over the last few years with COVID. Everyone tried to get their platforms onto the cloud so they could work remotely from home. So the likes of Microsoft, Amazon Web Service, they just exploded. So again, driving these large hyperscale data centers and the increased power. And alongside that, we're seeing growth in edge computing, low latency, bringing the computing power closer to the users. So in 5G, it all ties together and drives demand. And obviously, we can't only focus on the new data centers. We need to look at the legacy as well, because legacy, they're not all going to get retrofitted straight away. So we need to look at improving the efficiency of the legacy data centers. And all of this, efficiency, understanding carbon footprint, all fits within corporate and social responsibility. We're hearing it more and more these days about the corporate and social responsibility of companies. People and companies are leaning towards external agencies. So EcoVadis is one of the sustainability companies that people go to be able to benchmark how your company is doing against other companies. I have to say, I'm very pleased to say Socomec, we're in the top 1%, which a family-owned company, as you say, 100 years old, is really, really positive. So what helps to drive some of those key corporate and social responsibilities? We need to diversify energy supply. We've seen on the previous BP slides, we're too reliant on imported energy. We need to look at renewables. We need to look at solar and wind, etc. In the press this week, it was United Nations almost last chance saloon. We need to make the change. We need to reduce our carbon footprint and reduce greenhouse gases.
And I think to link that to what you said before, Richard, about not just monitoring new build, we also need to go back and look at existing installations and really collect that data and improve the efficiency in those sites.
We do, because we have to look at it as a whole, not just new build. The whole estate needs to be looked at. Integration of renewables. We'll have a look at that a little bit later. How can we best capture renewables and make it available when we need it, and reduce the dependence on imported fuels. So all this drive for energy efficiency has led to a number of performance standards. I think we're all very familiar with the ISO standards, 9001, which is the quality standard. Well, there's an energy management standard, the 50001. It's specifically looking at energy efficiency and energy management. And then we have a number of local low voltage installation standards, the 60364, which is the equivalent of the BS 8671. And then we have a data center specific 50600, which focuses very much on the data center infrastructure. And then below that, there's a number of metering standards that need to be adhered to. We'll see that within 50600, it calls and talks about efficiencies, and you need to have the right meters deployed at the right time. If we look at the standard, Chapter 2 is looking and concerned with power distribution, and Chapter 4 is the performance indicators. So within that falls the PUE, which we all understand PUE. We've been talking about PU for a very long time, but we'll see how that fits into the standards. So if you look at the standards, they indicate where you should be monitoring. So depending where you monitor depends on the granularity levels and how you are able to focus your effort. So the more granular, the more metering you have, the more you're able to understand your infrastructure and actually make the changes that are needed. And within the standards as well, it also mentions the accuracy of the meters, which is key. That there's no point monitoring a load if your metering is only 5% accurate, because if that's the case, your numbers and efficiencies you're seeing are meaningless, where the standards now specifically call for class 0.02 of the metering chain. The PUE, so Chapter 4 specifically mentions PUE, that was the performance part of the standard. Again, it specifies where you should be metering, and the more granular the metering, the higher the PUE number. So PUE 3 is where you're monitoring all the way through your infrastructure, right to the final load. And you can see within the installation low voltage standard, this is the equivalent of the BS 8671. The architecture follows that exactly the same. So it's basically specifying where you should be metering all the way through from the power input to your building, from your supply transformers or your generators, all the way through to the load that you're going to be supplying. So what are some of the solutions to be able to monitor? I think we're all used to metering AC and understand metering AC. I think what is key that we need to be able to meter at a new build level, but also retrofit. As I mentioned earlier and we said earlier, we need to understand that we need to improve the efficiency of the legacy data centres as well as the new build. So a modular approach, easy to retrofit, is really key for monitoring. And the ability to monitor DC now, I think, is becoming more apparent, because companies are starting to look at taking DC directly into the white space to improve the efficiency of the installation, such that we're taking out of the supply chain all the AC to DC conversions, which obviously have losses associated with them. So monitoring DC on the same platform is key. And you can see here where
perhaps, Richard, you could just go back to that previous slide and just explain the relevance of the RCM module in the network.
Okay, sorry, Colin. RCM is residual current monitoring. This is where we're able to monitor the installation such that we are able to detect if we've got a residual current fault, and the ability to continually monitor. So if you have that as part of your installation and your monitoring, it means that you don't have to do the annual or 5-yearly tests, because the standard was updated to say that if you monitor constantly, you don't have to do those.
Which is a big cost saving, I guess.
Huge cost saving. Yeah. And if you look at a data center trying to shut down a data center to carry out those tests is huge, as is with process environments as well. So just looking at some of the installations, so solid core, so that's typically a new build, so that would be installed as part of the LV infrastructure at day one. Split core, if you're going to do a retrofit, as I said, monitoring old data centers and legacy data centers is key. Flexible, so you can go around the whole data center, the bus bars very easily. And then DC on the far right, as I said, DC is becoming more and more important. And we're seeing that in a lot of installations now. Sustainability, total cost of ownership, it all falls and meshes together. So durability of the UPS, such you're not going to have to change it before its end of life, and make the best use of it. So making sure you have a fault tolerant architecture. Efficiency of the data center of the UPS, 97-99% efficient is absolutely key, so that you're making the best use of the power available. Resilience, as I mentioned, so segregated, so a single failure won't cause the whole UPS to fail. And the efficiency, as I say, looking at total cost of ownership, not just taking your day one investment. What's that system going to cost you over 10 years, 15 years?
And as we've detailed in previous presentations, Richard, Socomec has a number of tools to help people look at total cost of ownership as an example, not just for their existing system versus a new system, but also looking at different manufacturers.
Yeah, thank you. And use of catcher UPSs. I think we're seeing that architecture more and more now, Colin, aren't we?
Yeah, so this is where instead of having an N+1 type UPS application in each data hall, you would have one UPS in each data hall with one catcher UPS as the master redundancy, which would be connected via an STS network, obviously reducing not only your CapEx, but also your ongoing OpEx costs.
Yeah, thanks, Colin. And I say, larger data centers, so that the drive for larger UPS blocks, so, we're typically looking at 1 meg, 1.2 meg monolithic blocks now, but also looking at the larger modular UPS, such you can add or remove capacity as and when and as the load changes. So we're seeing a huge drive now in this type of architecture, where you have the flexibility to add and remove modules, online as and when you need to. Looking at the CO2 emissions of data centers, one of the key items is diesel generators. They're typically the backup of choice between the loss of incoming supply. You switch to diesel generator. Diesel generators are very polluting, so there's now a drive to look at using lithium-ion batteries, such that you can increase the runtime of the UPS and reduce the requirements and demand on the diesel generators. Lithium-ion technology has increased and moving at a very, very rapid rate. We're now looking at 15 years plus, 20 years plus life expectancy on lithium-ion batteries. The energy density is much higher than the typical VRLA batteries, meaning that you can get more runtime available in the same space, again, reducing the requirements on diesel generators. And as we mentioned, the edge computing, that has a specific requirement where it's a fairly constrained space. So you're going to be looking at rack mount UPSs, and you're going to be looking at lithium-ion batteries, so that you can get higher energy density in a smaller space. So that's really important. And diversified energy supply. What can we do to best capture the renewables that we have? This is a a typical installation. This is I have to say, Socomec installation where we're using the CATL batteries, a very well respected battery manufacturer, with the Socomec conversion so that we can capture the renewables and use them when we need to. And we're seeing that more and more these days. It's a native outdoor solution, has all the environmental control within it, so it's very easy deployed now. Whereas if you look back not that many years, that would be a much harder deployment. And we saw this week, the government is investing 1.6 billion on EV infrastructure for charging all these green vehicles that are coming onto the market. If you look, as you drive around now, the number of cars that have the green stripe on the number plate indicating that their EV is just increasing at a huge rate.
And we see that, I think in March 2022, more electric vehicles were registered than the whole of 2021.
I know.
So it's going to take off.
It's a huge figure, but at the moment there's not enough EV charging. But you can't just go and put all these fast chargers onto the network because the network can't support it. So that's where you're going to be looking at EV fast chargers together with energy storage, so you can take that peak out of the demand. And being able to look at different manufacturers and look at their data sheets. There's a drive now to actually verifying it. So PEP is an eco passport scheme where a number of players have signed up to it. I'm pleased to say Socomec have signed up to it, but you can see it's a lot of big players have signed up to it. And this is to ensure that the environmental data sheet that you provide on your equipment is verified. And it means that if you look at a passport from one manufacturer to a passport from another manufacturer, you can actually compare them. So you can actually make the right choice, which is the most economical to run, which is the most environmentally friendly product. So more and more companies are now signing up to this sort of scheme. And going back to the corporate and social responsibility, companies want to benchmark themselves. So when you're looking at suppliers, you're going to make choices based on, how green is that company? What is their philosophy? Are they a forward-thinking company and trying to make the changes? So companies are now looking to external certification bodies. These are the two main players. LEED, which is the American one, and BREEAM, I think we know, Colin, we've been looking at BREEAM for a number of years now, which is mainly the UK and European standard of choice. But people are now signing up to these so that they can benchmark themselves and prove to their customers that they are actually trying to make a difference.
So in summary, thank you very much for that, Richard. Very interesting presentation. So in summary, trying to consolidate what we've talked about this morning, we can see that sustainability is very important for all the actors that we work with, customers, suppliers. Education is going to create new actors in this market. So in 5 years' time, these people are going to be out in the industry. They're going to have a much better understanding of sustainability and the fields within it. We see international and local efficiency performance standards coming through, which Rich has already mentioned. The impact of many actions will make the difference across a number of sectors. Specifically, we've been talking today about data center, but it could be in healthcare, it could be in industry, EV charging, there's a number of those. And diversified energy supplies. Today we've heard in the UK that the government is planning 8 new nuclear power stations and much more onshore and offshore wind farms. Thank you very much for sparing time for us today, and look forward to seeing you in the future.